Awesome. So, hi everyone. Thank you for joining and welcome to the Dapr community call for February 22nd, 2022. My name's Nick Greenfield and I'll be the host for today's call. I'm also a maintainer on the Dapr project, specifically the docs repo. And for today, for today's agenda, we have a couple exciting topics. We're going to start off with going into a scenario where how to use Dapr with Apache APISIX Ingress controller, and we recently had a contribution to the Dapr blog outlining this use case, and so Yinlin will walk us through that scenario, and we'll also link to that awesome blog post. The next topic we'll talk about some action that's required for anyone that is running a Dapr deployment that's approaching a 1-year mark, and how there's some cert rotations that are required. And so Bern will give us an overview of why that is and how you can accomplish that. And then lastly, we have Shubham, who will talk about the an open proposal right now, which is for the Dapr offline installer. And then lastly, lastly, if we have time, the thing that we'll wrap up with is an open discussion. So anything that's top of mind, anyone have any questions about what we reviewed, that's the time to ask those questions, and you can always use the chat to do that. So no housekeeping items today. So without further ado, I think we can get into today's call. Yilin, you can take it over the screen and feel free to share your slides, and we'll talk about Dapr with Apache APISIX Ingress controller.
All right, cool. So I'll take over from now. Desktop 2. Great. So can you guys see the screen?
We can. Looks great.
Okay, cool. So today is going to talk about the a user case, or maybe a user scenario of enabling Dapr with Apache APISIX Ingress controller. So first is the agenda. The first part is intro, and the second part is why we should do this. Third part is what are achieved in this integration. And fourth part is a summary, and fifth part is a 2 to 3 minute Q&A, or if we do have the time for that. Okay, so let's start. So introduction about me and Shanyo. So I am a technical writer at API7.ai, and I was the previous maintainer of Venture Labs Chinese documents. Now I am a committer of Apache APISIX, and here's my GitHub page if any of you are interested. And Shanyo's introduction is listed below. He's the CEO at WHD, and he's some of the most valuable professionals at Microsoft, Tencent, and Huawei Cloud. Here is his GitHub page if interested. Okay, next slide is also an introduction. So WHD uses Dapr and APISIX Ingress controller in CMIT, or China Merchant International Technology, to migrate their container terminal operation system to the cloud. And the next slide answers the following 3 questions. Who are they, and what is APISIX Ingress controller? So WHD is a solution provider focusing on cloud-native application development and services. WHD mainly provides .NET and cloud-native technologies to build modern software with high productivity. And the reason Shanyo was not in this meeting is that he's on a business trip to Shanghai, and he's actually deploying Dapr in another user case where there's a manufacturing company wanted to use it, and he's busy deploying it right now. So yeah, next slides. This is an introduction about CMIT. So basically, it's like a port services where we got a lot of cargoes, a lot of containers moving around, and they have an operational system for it, and they wanted to migrate it to the cloud. And oh wait, am I stuck? Nope. Okay, cool. And the next slide is the introduction about APISIX Ingress controller. So it is a let's see. It is implementation of an Ingress controller. So the main difference from Angie's Kubernetes Ingress is that APISIX Ingress uses Apache APISIX as the data plane for carrying business traffic. And the next slide here is the architecture of the APISIX Ingress. So the APISIX Kubernetes is divided into two parts. The first part is the APISIX Ingress controller, which serves as the control plane for configuration management and distribution. And the second part is the APISIX proxy pod, which is responsible for carrying business traffic, and it is implemented as a Kubernetes CRD. APISIX Ingress controller supports not only custom resources, but also native Kubernetes Ingress resources. The reason why we integrate Dapr and APISIX Ingress controller is pretty simple. So the technology trend has been changed, and when I was making these slides, I made two memes that's pretty defined, it defines itself pretty well. So today we are experiencing a wave of development of cloud applications and microservices. Although some developers are familiar with the traditional web plus database application architectures, or some of you may call classic three-tier designs, some developers are not familiar with microservice application architectures. This is a pain point where integrating multiple microservices to build a cloud application. The developer's goal is to focus on business logic, while the platform is responsible for adding scalability, elasticity, and maintainability, and other attributes of this architecture to the application. So this is where Dapr and APISIX Ingress controller provide value. So here are some Dapr's advantages that we actually used. The first is Dapr supports multiple programming languages and platforms. It can codify the best practices for building microservice application into open, independent building blocks, which allows users to build portable, resilient, and secure application using the language and the framework of their own choice. Since each building block is completely independent, developers can decide to use one or multiple building blocks in an application. So imagine that building a cloud-native application is similar to building the Legos. You get to decide how and what you are going to build, and each block fits perfectly, and they are all hassle-free. In addition, Dapr supports multiple cloud providers, and it is not tied to any specific vendor. This means users can run applications in any Kubernetes cluster and other hosting environments that's integrated with Dapr. So with that being said, in order to maximize the advantages of Dapr, we need to find something that's suitable, that doesn't limit the advantages of Dapr. So the best choice we have is to integrate it with an Ingress that's highly customizable, high performance, and also hassle-free. After some research at YHD, we landed on the Apache APISIX Ingress controller. After talking about the advantages of Dapr, now we move on to some advantages or some fit points, or some match points of APISIX Ingress and Dapr. So first, APISIX is also an Ingress controller that's better than Cone and Nginx. The second point is it has an active community for problem solving, bi-weekly webinars, and new version releases each month with enhancements and bug fixes. The Apache APISIX Ingress controller also supports multiple programming languages in the data plane, and it is not vendor specific. Last but not the least, the Apache APISIX Ingress supports not only custom resources but also native Kubernetes Ingress resources. Okay. So here are some achievements. Oh, this doesn't show up. The first is after migrating CTOS to cloud, its architecture has changed a lot. So the next slide is the actual architecture of the CTOS after the renovation or after the migration. You may notice that the architecture is a bit complex here with like a bunch of arrows pointing from here to there, going back and forth. But because we are connecting with very many external services to achieve different goals, such as authentication, observability, logging, and a dashboard for monitoring. So we can simplify this by taking a request, for example. When a request comes in from this side, the left side, it first goes through the load balancer, then it enters APISIX Ingress controller, which decides how to send the request to a service efficiently. Then APISIX Ingress controller configures the same standard for Dapr annotation in order to inject Dapr sidecar for each service in the cluster. Once the decision is made, the request is sent to a service, and the sidecar deployed by Dapr handles communication with external services. By exposing the sidecars, external services such as Minio, Kibana, and Elasticsearch are able to communicate with services inside the cluster. Thanks to the sidecar, we can have resource isolation and increase the security level inside services and clusters. And another achievement is improved performance. Due to the cloud architecture, we are now able to decouple the CTOS application into different function modules. And because of doing so, we have increased the efficiency of the system and decrease the difficulty of maintaining the system. Okay, now is the summary part. First, Dapr and APISIX Ingress fit each other naturally. When integrating them, we are not sacrificing any of their advantages. The second summary is active communities give us confidence to use them in
That's not just me who froze, right? Okay.
Yeah, okay. Somebody just lost.
Yeah, let's wait a couple of minutes and give him a chance to come back.
Okay.
In the meantime, though, that was really interesting. I have a great many questions for him, so I do hope he comes back.
In the meantime, while we wait, I will show that I mentioned earlier that this scenario is posted on the Dapr blog. Can you see my screen? Did it go through?
Yes.
Yeah. So if you actually do want to go through it and read this in detail, and there's actually how-to instructions on how to enable this scenario, APISIX Ingress with Dapr. There's instructions on how to do that here. So for more details, see the Dapr blog. And with that, okay, well, go ahead.
Go ahead.
I was going to say we can always come back if we can move on and come back towards the end if there's time.
Okay.
Unless, did you have something that you wanted to add?
No, I was just mentioning that it's pretty interesting for me, at least, to be able to know where the metrics came from for deciding that APISX is faster than Nginx. So that's something I'm personally interested in. So if there's any links about that, I'd be happy to get them.
Oh.
And I think he's back.
Yeah, he's back. Ewan, are you? Let me make you. So you can unmute. You should be able to unmute.
Okay, cool. Sorry guys, my network dies just now.
No problem. And we can see your screen.
Okay,
so
cool. Okay, cool. We were at the second summary point right now. The second summary point is the active community gives us confidence to use them in production environments. The third is Dapr and Apache APISIX Ingress controller is definitely a 1+1 way more than 2 type of thing. And planning, well, actually, Shanyo is planning to provide feedback of actual usage and submit code for enhancements to upstream communities. He's been writing blogs for the APISIX blog website, and I'll try to urge him to do another blog when he finished this business trip. The last but not the least is, that's what everyone said, open source makes the world better. Okay, that's the end of my presentation. Any questions? Otherwise, we can end now.
Yeah, I have a bunch of questions, but I think I'll let other people the chance to ask before I go ahead. Chance to ask going once.
if you have any questions, please use the chat. As I know, only presenters can unmute, so the chat is open.
All right. So can you go back to the architecture slide, please?
This one?
I'm seeing the Q&A slide right now. The architecture slide, slide number 8, I think, or 14.
This one?
Yeah. Yeah, this one. So a few questions here. First, are you using Keycloak with Dapr middleware?
In the CTOS, yes.
Yeah, okay, so you were able to configure the Dapr middleware to actually authenticate to a Keycloak service. Is that correct?
Yes.
Did you encounter any particular issues or problems there?
This code was implemented by Shanyo. He may have some tweaks where he added middle layer between the sidecar and Keycloak, but I don't know about the deployment details.
Okay, because we did see a few users trying to use Dapr and Keycloak and they ran into some issues. So if there's anything he can contribute to the Dapr docs as to make this scenario clear, that would be really great.
Okay, I'll have a note really quick.
Yeah, no problem.
Cool.
And then the second question is for Grafana and Prometheus, are you using it to store only metrics related to the Dapr sidecars, or are you also using it to store metrics from the apps themselves?
I think he's using more than the metrics from Dapr, because well, it's this picture is the architecture of Dapr related things, but actually they do have a larger picture of the whole architecture.
Okay.
So imagine this Prometheus here. There might be other arrows pointing to it from other sort of, logging or monitoring stuff.
Yeah. And then the business services portion of it, are they written in .NET?
I'm sorry, what?
The business services code, the one that runs in the central box, is that written in .NET?
Some of them are, but I think not all of them are .NET. Some of them are.
Okay, so you have multiple languages using Dapr?
Mm-hmm.
Okay.
Yeah.
Yeah, no, that's good. And do you know, like, if they use the SDKs or do they use HTTP or gRPC directly?
I don't know.
Okay, that's fine. All right, well, thank you. This sounded like an interrogation, maybe more than just a bunch of questions, but this was really interesting. And I think you gave a really good presentation, so thank you.
All right, cool. I'll end it now and hand it back to Nick.
Sounds good. Thank you. Actually, I'm gonna let Bern share directly because he has some slides as well as sharing some other parts of the screen. So Bern, you can take it away with the Dapr deployments that are approaching 1 year lifetime and the certs that need rotation.
Okay, I assume you can see my screen.
We can.
Cool. Everyone's favorite subject, certificate rotation, is coming up and all the things that could happen, right? So here's maybe the really quick page that you could screenshot, or if you need to have one takeaway, here it is. And what happens is that Dapr will always generate a certificate bundle, whether or not you're using MTLS, whether you have that enabled. And so you need to eventually rotate those certificates. By default, they're expiring after 1 year. And so we have some instructions for doing that in different scenarios, and that's that URL on the bottom. And I'll get into more details, and let's recap for a second how TLS or MTLS works in Dapr, or more so, I'll just show you the architecture diagram. I'll pretend I know how it works, but Yaron is here, to answer questions if somebody had any about this. And the key things that I'm aware of, at least, are the service-to-service communication, where you can enable MTLS for service-to-service communication securely. So here in this case, the sidecar for like app deployment A and then service B here. Another thing is this was supposed to be a different graphic. Oops! But there's another graphic on this concept page where you can see that the sidecar communicates securely with the control plane, for instance, with the actor placement service. So that's one use of these certificates. And another is for the control plane to securely communicate among itself. And even if you didn't explicitly enable TLS, so the default is that TLS in the Kubernetes deployment, I believe TLS is enabled by default, MTLS. But if it is not enabled, if you set it to false explicitly, there is still a TLS certificate being generated, and that is being used by the control plane for its inter-control plane communication. So you need to rotate that. And you can check whether or how long you have before you must do this by running the command Dapr mtls expiry. And so you will be able to see when the trust bundle, the certificate bundle expires. And there are two ways we can rotate the certificate bundle. The first one is how you probably got the certificate in the first place, which is you didn't even know you had one, maybe, because Dapr generated a certificate bundle for you. And we can take a step for Dapr to generate a new certificate bundle. Or you could generate a certificate, some certificates yourself, and then explicitly provide those and to the Dapr control plane and deploy that. And all those steps for those are on this documentation page here that's now updated. And I will demo the first of these approaches for telling Dapr to generate new self-signed certificates. Okay, so I have my Dapr up and running, and we can just check the expiry here of my existing trust bundle. And looks like they're expiring in less than 2 days. Oh no, must hurry and deploy new certificates. All right, so in the documentation, I'll go there and I'll show actually how I would be using this. So what we can do is we can actually clear out the existing trust bundle, and we can do that by just using this snippet here and applying this secret with kube control. So basically clearing out the data section. I already put the file here, so I can do apply, and my namespace here is Dapr system. And that's now cleared out, and I can confirm that by, let's see, get secret. This thing is called Dapr trust bundle. And I want to maybe view the output in YAML format. So now you can see there is, you don't see the certificate in here. There's nothing in here because we cleared the data section. So far, so good. But what we need to do next is actually restart the Sentry service, and then Sentry will generate a new certificate for us. Rollout restart, Dapr system, Dapr Sentry. And I like to just look at the secret, and you can see Sentry is already restarted, and then on restart generated certificates for us. So now we have the new certificates here, but we also need to actually use them in all the places. We need to restart other control plane services, and then our applications. So I already have this in my history here. So I'm going to restart the operator and then the Dapr replacement server stateful set. And let's do the status here to see. Yep. Okay, so for the time being, all my existing deployments are totally fine. I have silly app running here, which is doing service invocation with MTLS, and the caller apps calls this receiver app, and the app is totally fine. Nothing changes. But if I were to restart one of them, it will pick up the new certificates, and it could potentially then cause downtime for the other app. Now, that's something that's unavoidable at the moment. You would have to deploy both the caller and callee app as quickly as possible to avoid the downtime. The workaround there is if you bring your own certificates and you ensure that you use the same private key or the same root password for your certificate, even when you generate a new one, use the same private key, then the certificates are compatible with each other and you wouldn't have any downtime even if you restart services. So in our case here, I won't really show you that there might be an error, but I'll just deploy it quickly together, and that's the best you can do. So in my case, I'll just do rollout, restart, deploy, invoke caller, and invoke receiver. I'll just look at the pods for a second. And the caller will error in my case until the receiver is up because of this mismatch in certificates. I didn't have any error handling in my sample app here I deployed. But anyways, they will recover, and so everything will be fine in a moment here. Anyways, I've done it so many times, so you have to look into that. So a couple of other things to then mention. So as I said before, you could bring your own certificates. There's a section here for how to generate them. You can look into that. The key is to use the same private root key later, when 1 year later you, or whatever time you specify, you want to rotate the certificate, use the same root key if you can, because then you can really avoid downtime. And if you are one of the people using MTLS, the Sentry service in standalone mode, then we also updated the documentation for that. So just take a look. Everything is here on this page, and that's all I have for now.
Cool, thanks, Bern. Any questions? Please feel free to use the chat. I'm not seeing any yet, but we can always come back at the end.
We should probably tweet from the Dapr Twitter page, reminding people to rotate their certs.
Okay, we can do that.
And my application is actually healthy now.
That's good to know. It was hammering in my head. I was like, is Bern's app gonna be okay? That's gonna annoy me all night.
Oh, I will show you. Look.
Oh, thank you.
Yes.
Yeah. No, I believed you, but yeah. Before I've seen it, I was worried if your app will eventually be okay.
You can get some sleep tonight now.
Yep, I'll sleep like a baby.
Awesome. Well, thanks, Bern. Really informative. And yeah, I agreed, Jeroen, we should be putting this out there for folks to see and at least have instructions on how to do these cert rotations. Okay, so I want to move on for the sake of time to make sure we do have time for open discussion. So Shivam, I believe you are going to take over and talk about a proposal that we currently have for the Dapr offline installer.
Yep, I will quickly share my screen. Let me know if it is
we can see
visible.
it. Yeah, we can see it.
Okay. So hi everyone, I'm Shivam. I've been working in Microsoft IDC for the last 6 months, and basically this discussion is about the Dapr air gap installer that we have been working on, and it's mostly to be like asking feedback from you about like we have multiple approaches being in discussion, and it is basically about asking feedback about which one do you think should be the way to go forward. So I will quickly just enunciate what is the purpose of it. So the purpose of this standalone or air gap installer is to have the support for Dapr installation when there is no internet connectivity, basically an offline installer. So currently, like if a user has to use Dapr, so they would have to first install the Dapr CLI and then run Dapr init, which basically like pulls up the different binaries like Dapr runtime dashboard and all. It pulls up the container, like the placement container for Docker Hub. It also pulls up the third-party containers like Zipkin and Redis, and runs up the containers and all. So all these things like Dapr init does, and it requires internet connection to pull these binaries or containers from Docker Hub and GitHub. Also, a user can do like normal Slim installation where we don't like run up the container, only binaries are installed. So the air gap and or like standalone installer is basically expected to have like the same support so that the user could install it in an offline environment. So as I said, like there are currently like 3 sort of designs that are sort of being in discussion. One approach that was most basically sort of arose from the Phil's POC that he had done on it. So the first design is what, like the idea is that what we can do is that we take all the binaries like the CLI, Dapr runtime, dashboard, and the Dapr placement image. All of them are like sort of downloaded, and they can be all combined into one executable like Dapr standalone.exe. And when and the user simply has to like run that binary, the standalone installer, and then it will like install the binaries and it will load up the placement container by default. I am not like very much comfortable with shipping the third-party images as well with this binary like the Redis and Zipkin, because that would basically have the dependency of the installer on the Redis and Zipkin. And so like whenever suppose there is a new release for Redis or Zipkin, we would have to update our standalone installer as well. So for that, I'm thinking of not shipping it with the standalone installer, but what we can do is that user can like they can either manually pull and run those containers, or they can have the images saved as a file and they can provide that as an input to the installer, and it will load them up for them. Slim installation will be like supported, where just the binaries would be installed. And also I think that it cannot be done in the CLI itself. We need a separate repo for the installer. And the reason for this is that it has sort of like the dependency on the CLI, Dapr runtime, and as well as the dashboard releases. So once all of these are released, only then this can like pull them up and then combine them up into a new binary and then have a combined installer. So I think we would need, at that point, we would need to have a separate repo for that. There are like certain advantages and disadvantages of having this approach. One advantage is that they like it's sort of a relatively easier dev experience because it's like just the user has to simply download the installer and run it, and everything will be done. They won't have to like do any extra work for that, except for the Zipkin Redis part, which they have to pull it up. However, there are like certain cons, as like negatives and positives are always there. So basically, the one major disadvantage sort of is that we would be now there is two sort of major disadvantages for that. One is about like there will be a little bit of code duplication, because mostly the installer, like in part, it will be doing the same set of things that are being done currently in the Dapr init. In the CLI, and then because it will be in a separate repo as for now, so it will require further maintenance as well. And then there will be like sort of now after this install, it will be like the user would have the two sort of executables for installing Dapr. One is the normal Dapr CLI where they can do Dapr init, and then the other is the standalone installer for the air gap environment. So like if with this approach, it can the user had to simply run the standalone installer with the path to like the Redis and Zipkin images if they are not being shipped along with the standalone. Right. So very simple thing. Actually, the idea is very, very common in all of 3 approaches, but like the main idea of the first approach is that it is like all combined into one common executable, and the user has to simply run it. That's all. The second design that is in discussion is to not have a separate standalone, like not have a separate executable for air gap environment. Instead, what we can do is that we can simply, like, all the binaries and the images, they can be like just released as an artifact, basically like something like a zipped folder, Dapr bundle, which contains, like, in a structured way, all the binaries as well as the images. And then we simply enhance the Dapr CLI itself, or Dapr init itself, which then takes as input that bundle that would be releasing, or that folder, and then it will pick up from those files instead of pulling it from the GitHub. So currently, like, the Dapr init pulls it from the GitHub. It will be sort of overridden if the user provides that bundle as an input to the Dapr init. Again, like, bundling the Redis and Zipkin images are not, I'm personally in support of, because of the same issue. We would need to have multiple releases as the Redis and Zipkin are released. And again, we would need to have a separate standalone repo. But now, like, in this case, the repo will simply have a workflow file, and that's all. There will be no code or something there. It's simply a workflow file which will run at whenever there is a new release in either CLI, runtime, and dashboard. So the artifact could be structured like this, simply like there's a bundle where there's a bin folder with all the binaries, and the images are there with the placement. If we agree, we can also put the Redis and Zipkin here, but like, it has its own issues, as I said. One major advantage of going with this approach is that it would, like, lead to sort of decoupling Dapr CLI with the artifact. So we now sort of, like, the Dapr CLI is enhanced to have that take a folder as an input, and then the Dapr bundle is released separately as an artifact, and the user can simply take it. And it because there is, again, no code duplication, so it's sort of better in that sense. We don't have to do a large maintenance work there. And also, it leads to a little bit of consistent user experience, because, like, in normal environment, a user does Dapr init to install the normal Dapr, and then even in the air gap mode, they will be basically using the Dapr init itself, but it's like just a little bit modified way. So basically, it will be something like this. So say that this Dapr bundle is being released as a zip file or as an artifact. The user has to download it and then unzip it, and they can simply run this command where it's like it's just the Dapr CLI with Dapr in it, and then the bin folder can be provided as a path, and similarly the images folder can be provided as a path to that, and then it will be like the Dapr init Dapr CLI will pick the binaries and the images from here, and it will load them up and install everything for the user. So yeah, so this is sort of the second approach, and then we have a third one. One of the contributors, Ian Luo, he recently created a PR in Dapr CLI with this approach, the third design, in which we basically, the idea is that instead of again having a separate standalone installer like in the design one, what we can do is that we could have sort of like two versions of CLI itself. One is the normal CLI that we are releasing right now, and the other is like a sort of a fat or air gap CLI, which has like the CLI bundled with all the binaries and the images, everything. So so it's like basically like normally for normal installation, a user has to use normal Dapr CLI and do Dapr init. With air gap CLI, it will be like again consistent and sort of the easiest dev experience for the user. They would simply have to download the air gap CLI and do Dapr init there, and then it will like pick up the binaries and containers and load them up, everything. It will and one more thing is that it does not need a separate repo, because it is like being part of the CLI itself. So it's like and it's it will also be a part of the CLI release workflow itself. So there is no like need for separate repo as such there. And the advantages is that as I said, it like leads to a consistent and easiest dev experience. Like instead of like the Dapr init using normal CLI, they simply have to use the air gap CLI, and that's all. and again, like in the PR that was created, it was like the Redis and Zipkin images were also being bundled up with that. So again, if there's the positive and negative of that is that if we bundle it up, we would need to have probably a new release for every Redis and Zipkin releases. But the downside is that if you don't, then the user has to do it manually. So that's it. And one disadvantage or cons with this approach is that initially without like having a separate repo, because it is a part of the CLI itself. So now suppose whenever there is a release or hotfix in Dapr runtime or dashboard, we would still need a new version of air gap CLI at that point. So basically now we would basically have to have a new version of CLI with Dapr runtime or dashboard releases, which is like little hard to incorporate. And then second thing is that basically air gap CLI is just required for the installation part, right? After that, a user can simply do it with it using normal Dapr the way she uses. So, but then using a whole like big fat binary just for the installation part is something also can be considered as a cons. So these are like sort of the three major approaches. As I said, it's the core idea is basically same. We have to simply ship all the binaries and the images in one common place. Just the structure in which we do it matters. So I basically sort of first started with the Phil's POC itself, where it is like the designed one where it is all downloaded and combined into one common executable. So I can quickly show it up that how it happens there. I hope you can see my terminal. So it's sort of like I have already sort of downloaded everything. Let's say the binaries and everything are being downloaded. The image is being like the replacement image is pulled up. So I just have to do make build, and it will create the standalone executable for me. Now for like normal, like say for the Slim installation, I simply have to run it. And it will like download the binaries, and it will not basically like pull up the containers. Just doing a normal, by default it will download the binaries, as well as it will like run up the placement container. So you can see the placement container is up and running. And then in the last case, when the user also needs to have the Zipkin and Redis files, so they again they can like have it manually. They can like simply manually run the Zipkin and Redis containers, or they can like simply save them as a file and then provide that as a to the installer. So it is something like that. Just basically you just save as a tar.gz file, and then you provide them in the executable, and it will like load them up both Zipkin and Redis containers. So the normal Dapr is installed, everything is done, and that's it. So this is the idea. This is sort of the design one. I guess it's like all these are very much similar in its essence. But the chief idea is that how are we going to go about it? So I guess that's it. Any comments, any suggestions?
Hi, this is Arthur. There is one thing that we might be able to do on design queue. We might be able to do some convention where the CLI can discover where the binaries are, so we don't require the extra parameters. So I think that we might be able to play with that a little bit to say, oh, it would auto detect if the binaries are in the same folder as the Dapr binary, or the images is one level below /images. So I think we might be able to play with that a little bit in the design. So you might get closer to like a Dapr init experience, even for the first option. And I would even imagine that we might be able to, let's say, have a convention where there's a .dapr CLI folder in a home folder, where you can actually have multiple versions of Dapr there, if you want. And and automatically have that as a cache where we can do the Dapr init experience seamless, regardless of you knowing if it's going to download or not. So I think we can play with that a little bit more as well if you want to avoid having a separate installer and still have the Dapr init experience with no arguments.
And Arthur, that's the feedback you gave Bayway, right, in his PR?
Yes, that is aligned with the PR, with the feedback I gave on the PR, is that we can have that convention, and that can be very easy also for you to install multiple versions. You can have a thumb drive also if you want to install Dapr with every version of Dapr ever release if you want. So that was my feedback. That we can even, I think, was one advantage of Design 2 is that we can retroactive make that bundle with previous version of the runtime. We can have, of course, the latest version of the CLI with the new enhanced Dapr init, but we can retrofit and create bundles with previous versions as well if we want.
My main question is what's the driving factor for this other than edge deployment of scenarios for production?
So Mark, one of the users who asked for this is I think it's the Ministry of Interior Affairs in Israel, and they basically said that their entire environment is disconnected from the internet, and they actually need it for local development. So that's one use case that was pinged about for not for a production environment, but specifically for a local development experience, just because the developers' machines are just disconnected from the internet entirely.
Yeah, and there is a related issue that is not this one necessarily, and that is why I'm leaning towards Design 2, where we're going to enable Dapr CLI to install Dapr from other registries that not Docker Hub.
Yeah, I mean, that would make sense to me. I think Design 2 is the only worthwhile one. I think you have to go down the approach of having a single CLI, and it can just read a directory of structures that you've copied off the internet or from one place and store them on a local drive, as it were. Building another CLI seems crazy to me.
Mm-hmm.
Yeah, I wouldn't use the word crazy, but I think it's like it would definitely be far more maintenance.
It'd be a massive maintenance burden for no great benefit, if you ask me. Almost no benefit. So three's out, one-ish, two for certain. And if the scenario is, yeah, I'm a military organization, my computers don't attach to the internet, and I've got to go and get my stuff off, and it all has to come through firewalls that I zap. No one can bring any form of USBs or media in. You get scanned and security checked every day, and everything gets checked. Then I can understand.
Yeah, but so here's the example. Thanks for bringing this up, Praveen. So this is the feedback I provided to contributor Bayway 30, where I've offered a versioned structure where you can even unzip this into your home directory, and the Dapr CLI can understand the Dapr CLI folder structure, and you can say, if you're installing Dapr 1.7, we know exactly where to get that from. So we could even play with that a little bit. So that was just one of the ideas.
So Arthur, I haven't looked at Bayway's PR, but it doesn't build an entirely new CLI, right?
It does not, but that is the Design 3 that Praveen was showing today. It's where he takes the design, he combines kind of a mesh of Design 1 and 2, where he creates a fat Dapr CLI binary.
It'll be so hard to maintain that.
Where he literally compiles the images into the CLI binary. So when you download the CLI binary, it's going to be much, much larger because it has all the binaries baked in.
Yeah, also related but not directly, the moment you realize that the Docker image is nothing more essentially than a tarball wrapped in another tarball is a very sad moment.
Yeah, we have to be really careful about creating new forms of packaging technologies and all sorts of other things. It's just like, yeah, this is just copy onto the file directory and have a way of reading it.
And the one thing that from Design 1 and Design 2, the experience is very similar if we have this convention for a folder structure, because it's unlikely that you're going to download the binary directly, right? You have to download the zip version of the binary, and then you uncompress and run the standalone installer. So the design tree will be a very similar experience. So you have a tar that you unzip, and then you have to run one of the binaries. So it's going to be very similar, not quite as convenient, but I think the difference in convenience is very small for the actual maintenance.
So Arthur, like just for clarification, so when you say that it is like the CLI sort of understands it, so user would have to download the tar or zip, and then would have to place that in this suitable folder, right? Like this.
So this
like in the home directory or something.
Yeah, in this example, the tar.gz has this structure already, right? So .dapr CLI/10 whatever. So he would have to go to his home folder and unzip this bundle, and then it will already fall into the right folders. And from that time on, he just have to run the binary, and then we can have this convention that we auto discover where the binaries are, so there's no command line argument.
Okay. Yeah, that looks good.
But then we would need, I still need a second another repository to get the bundles, because I think your proposal for design one is correct, where we need a separate repository, because you can have a release of the sidecar, but not have a release of the CLI, but still we need a new bundle, right? So you need to kind of combine those two together. And versioning of the bundle will be interesting. How do we version that? So that will be an interesting discussion, but maybe after we decide between one design or the other. So my vote, I'm actually advocating for design 2, and others might be here as well, but I will ask people to please comment on the issue, put your opinion there, and we can move forward.
Yep, I think exactly the call to action here is input from the community. This issue can be found in the CLI repo, issue 731. So really appreciate any feedback around the 3 different options.
And thank you very much, Praveen, for presenting all options here.
Yeah, I'm Shivam, but it's fine.
Sorry, Shivan, sorry.
It's
okay.
Fine. Yeah, over to you, Nick.
Yep. So thanks for that presentation. And that wraps up today's call. Unfortunately, we don't have any time for an open discussion. So I think we can definitely make sure the next call that we will have that time allocated. So I want to thank all the presenters for tonight and the questions. Great discussion. And yeah, thanks for tuning in, and we'll catch you in 2 weeks.